Hello everyone, welcome to another video. Today we're looking at the sine and cosine ratios today. So first we're going to look at this triangle here, and we're going to write out the names of some sides and some angles. So if we were in this corner right here, so if I put my theta there, again remember theta just means angle. Okay, so if we were in this corner here, I'm just going to put a little guy standing there. Again, in today's stuff, we're going to want to be able to know how to label our sides. So if I was going all the way to the far side, we would call that the opposite side. If this is my 90 and I'm going to go across from that to this really long side, remember our long side is called the hypotenuse. And then the last side, which is really close to the angle there, it's close, which means nearby, and another word for that we use is adjacent. Okay, so we've seen all of these terms before. We saw those in our first lesson on the tangent ratio. Okay, so today we got two new ratios. They're the sine and the cosine ratio. So we're going to start by writing out those ratios, just like how tan from last day, tan theta, it was opposite over adjacent. Now we're going to have some new ratios where they're just using different sides. So the sine ratio, sine theta, is going to be short form written as sine theta. You don't got to put the e. And this is opposite over hypotenuse. Okay, so the short way to write that, we just put O over H. Okay, and then the cosine ratio, to write that a little bit shorter, we just put cos theta, and that is going to be the adjacent divided by the hypotenuse. Okay, and then the shorter way for writing that, we could just put cos theta is A for adjacent, and then H for hypotenuse. Okay, so these are our two new ratios. And these two new ratios, along with our tangent ratio from the other day, they are what make up what we call the primary trig ratios. So these are the three trig ratios. They are sine, cosine, and tangent. Okay, and then the way that we can remember this is this little acronym. It's SOH CAH TOA. Okay, so the SO is for sine is opposite over hypotenuse. So sine opposite over hypotenuse. The CA is cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And then the TOA is the tangent is opposite over adjacent. We had that up here. So tangent is opposite over adjacent. Okay, SOH CAH TOA. And then them written out the long way. This is just the same thing, but we're using all of the letters. We're actually writing them all out. So this right here, this is going to be really important. Okay, so I'd remember that SOH CAH TOA. Now none of this though you guys have on your formula sheet, so not on formula sheet. Okay, but SOH CAH TOA, it's not too hard to remember. Okay, so getting into our first examples here, it says write each trigonometric ratio. Okay, so the first one we got here is sine L. So we're going to be standing at the angle L. So I'm going to put my little guy standing at L, and then I'm going to label my sides according to that angle. Now the one side that's never going to change is across from this 90. This side here, that 13, it's always going to be the hypotenuse. Okay, but if we're standing at this angle at L, all the way to the other side, that's going to be the opposite side. And then this close side here, that is the adjacent side. Okay, and sine we had up top here, it's just opposite over hypotenuse. So opposite over hypotenuse, O over H. And because I labeled this, I see what O is and I can see what H is. So O is going to be 5, and then H is 13. Okay, so as long as we can label our triangle, it makes these questions here go quite smoothly. So we got 5 over 13. Just make sure you can't simplify that fraction, and in this case we can't, so we're done. Okay, then we're going to do B, cos of L. So again, I'm standing at angle L, so my stuff is already labeled. And now cos, we had up here, was A over H. So I got A over H. And then A is 12, H is 13. So I got 12 over 13. Then again, just make sure you can't simplify, and we can't. Okay, moving on to sine of M. Now we're looking from a different angle. So now we're looking from M. So I am going to do this in a different color. So now we're at M. I'm going to put my little guy standing at M there, and I'm going to label my stuff according to that angle. So all the way across, that is the opposite. This long side is still the hypotenuse. So that side still hasn't changed, still the hypotenuse. But this other side here, this close side, this is now the adjacent. Okay, so it all depends on where you're standing from. So again, sine we said was O over H. And O, if I look at the diagram, is 12. Again, I'm looking at the blue stuff, so it's 12 over, and then the hypotenuse, 13. Okay, and then check if you can simplify, and can't simplify that. Okay, next we're on to cos M. So cos, again, we had it up here, A over H, adjacent over hypotenuse. And then we look at our labeled sides, so A in blue is 5, hypotenuse 13, so 5 over 13. And that one we can't simplify either. Moving on into example number 2 here. And it says for these, solve for x. So looking at the first one, x is right here, so we're finding a side. And the angle we're given, again, we always want to be going from the angle, that's going to be important. I'm going to label my sides from that. So this is the 90, so that makes this long side here, that's got to be the hypotenuse. Okay, and then all the way across, that has to be the opposite. Is that the opposite side of the triangle? Now in this case, and in these questions today, because we have 3 options, we have sine, cos, or tan, and I'm just going to write those at the top here. So because we have 3 options to choose, we're going to have to pick the one that will work with the triangle that we're given. Okay, so in this case, if we have opposite, O, and we have H, hypotenuse, we're going to try to find the one that has those 2 sides. So if you want to try to pick it out, you can try pausing it and picking it out. And the one that we're going to use, it's got to have O and H. So this one has an O and an H, so I'm going to use SO. I'm going to use the sine. So sine theta is opposite over hypotenuse. Okay, and then we just start to fill it in. So sine of 62 degrees equals opposite was x, and then hypotenuse in the bottom is 20.3. And then once we got something like this, you can just put this side over 1, and we're going to use cross multiply, divide to solve. So these two we will multiply, and then we will divide by the one across from the x. So x will equal 20.3 times by sine 62, all divided by the one across from the x, which is a 1, so that actually won't change anything if we divide by 1. And then we're going to put that into our calculator. So I'll pull out my calculator, turn it on. Okay, and then we're going to type in 20.3 times sine 62. Okay, and then we'll click enter. And we get 17.923. So let's write that down. And in this question, it doesn't say what to round to, but most of the time we like to round to the nearest tenth. So we're going to round this to the nearest tenth. So there's the nearest tenth right there. And this 2 is not going to round that up. So we just get 17.9. And then our units, we had meters. So that one is done. I just want to make a note of your calculator. Make sure your mode that you guys are in, you have to be in degree mode. If you happen to be in radian mode, you're not going to get the right answer, okay, because this is using degrees. So you got to have degrees on. Okay, so I'll move my calculator and we're going to start number 2. So in this one now we got this angle here, so we're going to be standing from there. There's the 90, so I know across from that, that's got to be hypotenuse. This really close side, that is the adjacent. Okay, so if you guys want to pause the video and try to pick which one you think we're going to use, and then if you want to try to solve it, you could do that. Okay, so I see we got an H and we got an A, so I am going to use the one with an H and an A. I'm going to use the CA. So we got cosine theta is A over H, and then we'll fill it in. Cos of the angle, 37, equals adjacent is 18.5, and then the hypotenuse is an x. Okay, and then again, put this over 1 and do your cross multiply divide. So x is equal to, we're going to multiply these two. So 1 times 18.5 divided by cos of 37. Okay, and then we'll put that into our calculator. So get our calculator back out. And we'll type this in. And we get that 23 number there. So let's write that down, 23.1645. And then we're going to round it to the nearest tenth again. So 23 point, look at the 1. The 6 in this case is going to round it up, so the 1 goes up to a 2. And then this one was measured in yards. So there is the answer for that one. Okay, and then we'll move our calculator out and we'll do the last one here. So again, step 1, we're going to put our guy at the corner, label our sides. This is 90 degrees. So all the way across from it, this really long side, that is the hypotenuse. And then right beside the angle, that is the adjacent. So I got an A and an H, the one with A and H, that's the cosine. So we got to use cosine. So cosine theta equals A over H, and then we'll fill it in. Cos of the angle, it was X. A is 20.4, and then H is 30.3. Okay, and then these ones where you're finding an angle, these ones are a little bit different. These ones when we're finding a side, you can do that cross multiply divide to get your answer. With one where you're finding an angle, we got to do something a little bit different, and we saw it when we did the tangent stuff in our previous lesson. What we got to do is we got to try to get rid of this cos in here. And the only way to get rid of a cos is to do the opposite, so that's cos inverse. So I got to take cos inverse of the other side as well, and then cos and cos inverse cross here, and then the only thing that's left is x. So I got x equals cos inverse of 20.4 divided by 30.3. Okay, and then we're going to type that into our calculator. Okay, so cos inverse is, we got to click the second button and then cos, that'll get you to cos inverse there. And then it'll open up the bracket and then go 20.4 divided by 30.3. And make sure you close your bracket. Okay, so we got 47.6802. And then with our angles, usually we like to round these to the nearest whole. So we don't want any decimals. So in this case, the 6 is going to round that up. So we get 48 degrees. Okay, and now that one is done. Now just a note about solving these questions. Make sure you guys show your process. I should see a formula, then we should have it filled in, then we should have some solving, and then you should get down to your final answer. Okay, each one of these kind of parts is going to give you a mark. even if you can write down, say, the sine ratio, that'll give you the first kind of mark, and then you'll keep getting a mark as you go. Okay, moving to our next question, and here we got a word problem. So number 3 says a guy wire supporting a tower is 24 meters long. If the guy wire is attached at a height of 17 meters up the tower, determine the angle that the guy wire forms with the ground. So I'm going to draw a simple picture to start off. Then I'm going to draw my tower. So let's label our information on here. So it said the guy wire is 24 meters long. This is the wire right here, so that's got to be 24 meters. And it said it was attached at a height of 17 meters up the tower. So 17 meters up the tower. So that makes this 17 meters. And we want to determine the angle that the guy wire forms with the ground. So again, guy wire with ground. If we shade those two, that's going to tell us the angle. We want to find that right there. Okay, so we want to find that angle. And from that angle, so it's like we're standing right there, going to label our stuff. That's the 90. So this is hypotenuse. Across from the angle to the far side, that's the opposite side. So we got an O and an H. We got to use either the SOH, the CAH, or the TOA. So we got to use one of these three. And the one that has an O and an H is the SOH. So sine theta is O over H. Then we fill it in. So sine of theta, I don't know what theta is. Opposite is 17. And hypotenuse is 24. Okay, and then to get rid of the sine, we got to take sine inverse. So sine inverse this side, sine inverse the other side, and sine inverse, those two cancel out. That's what I wanted. So the only thing coming down is the theta. So theta equals sine inverse of 17 over 24. And then we take that, go put that in our calculator. So second sine bracket 17 divided by 24. Okay, so we got that all typed in. Click enter, and we get 45.09. So I'll move this out of the way. 45.09 degrees. And then angles, we're going to round to the nearest degree. 0 is not going to round up to 5, so I just get 45 degrees. Next, we're on to number 4. Number 4 says a pilot starts his takeoff and climbs steadily at an angle of 12.2 degrees. Determine the horizontal distance, so that's left to right. The plane has traveled when it has climbed 5.4 kilometers along its flight path. Express your answer to the nearest tenth of a kilometer. So this one's telling us what we got to round to. So first, let's start with our picture. So I'm going to draw the ground. I'm going to draw a very basic picture of a plane. Okay, and then that plane, it's going to take off and it's going to go into the air. So we got a triangle looking something like that. There's our 90. Okay, and let's read the information again. It said he climbs steadily at an angle of 12.2 degrees. So that is going to be how much he is going up here. So 12.2 degrees. And then it asked us to determine the horizontal distance the plane has traveled. So horizontal, again, horizontal is left to right. So the only side that is left to right is this one right here. So we're going to put an X right there. I want to find that. And the next piece of information, it said when it has climbed 5.4 kilometers along its flight path. Okay, and the flight path, that is the path that the plane actually took. So the plane goes up and it starts flying along this line. Okay, so that is the flight path. So that is 5.4 kilometers. Now that I got my picture, and we know we're standing in this corner here by the airplane, I can label my sides. So this really long side across from the 90, that is the hypotenuse. this close side, that is the adjacent or nearby side. So I got an H and I got an A. And the only trig ratio with an H and an A is the cosine ratio. Okay, so got a ratio, then fill it in. 12.2 is the angle. Adjacent is X and H is 5.4. Again, these just come from A is X, hypotenuse 5.4. Okay, and then I can put this over 1 because I'm not finding an angle, and I can do the cross, multiply, divide. So I'm going to go multiply 5.4 times cos of 12.2, and then divide by the 1 across from x. So divide by 1. That's not going to change anything though. Okay, and when I type this into my calculator, you should get 5.2780. And some more decimals. And then rounding this one, we wanted to the nearest tenth. So the nearest tenth, there's the tenth. Okay, and the 7 is going to round that up. So you get 5.3, and this was measured in kilometers. Now questions like this too, you can always check your answer at the end. I know the hypotenuse here, that always has to be the longest side. So if this is 5.4, whatever side this is, it can't be more than 5.4. It could be close to it, but it has to be less. So 5.3, that would make sense, okay? So you can always do a quick kind of check. Hypotenuse has to be the longest side. So moving along to our last one here now. So this is our problem of the day. If you guys want to pause it and then try to do this one on your own, you can. We are trying to determine the values of x, y, and theta. So there's 3 things we got to find. And I'll give you guys a hint. You're going to want to start with the triangle where we have at least 2 pieces of information on it. Okay, so I'll give you a hint. You're going to want to start at this triangle right here. So start at that triangle right there, and you got this angle in it, and you have this side at the end of it. Okay, this bottom side is the whole length. It is not this part of the triangle. It is the whole way, all the way across. Okay, so use that hint, try to find x, y, and theta. Now for actually solving this, I know I'm going to start with this triangle that I had drawn there. The side all the way to the other end here, that's going to be opposite. Okay, and this is my 90, so across from that means that is the hypotenuse. Okay, so I can use that to find this hypotenuse side. So I got an O and an H. O and H is going to be the so I'm going to use sine first. Then we're going to fill it in. So sine of the angle is 20 degrees. Opposite is 3.50. And then the hypotenuse is y. Okay, and then we're going to put this over 1 and do our cross multiply and divide. So y is going to be equal to, cross multiply these two, and then divide by that one. So divide by sine of 20 degrees. And then throwing that into our calculator, you are going to get 10.2333 and then some more decimals. Okay, so I have found y. Now I'm not going to round that because I might need to use that number later and I don't want to round it early and then it throws off my other values. So the next one I am going to try to find, I'm going to use the information on this triangle, like this opposite side and this angle, and I'm going to try to find this adjacent side, because once I have that, it's going to help me to find this piece right here, and you'll see after how we'll do that. So this is adjacent. Okay, so I want to find that, and if I am going to be using the information on this triangle, I want to use known stuff. I don't want to use this just in case I got this wrong. So I'm going to use opposite and A, and the one that uses that is the TOA. So I got tan theta is opposite over adjacent. And then tan of the angle is 20. So tan of 20 degrees equals opposite is at 3.50 over adjacent. I'm just going to use the letter A. And then I can put this over 1, do my cross multiply divide. So these two will be the multiply. So 1 times 3.50. And then divide by that tan of 20. Okay, so putting on my calculator, I'm going to get 9.6161 dot dot dot. There's more numbers after that. Okay, and now that I know that, it didn't tell me to find that, but if I know that this is about 9.6-ish, okay, the whole way is 14.5. So if I were to take this whole thing and then remove this section, it'll give me this section. Okay, so picture it like this. This whole section I just found is 9.61, that one. And then I want to find this little section. I'm going to call it Z. Okay, and once I have that, I'm going to use that to help me find X because it's inside of this triangle here. Okay, so Z is going to be equal to, if I took the whole length, 14.50, and then I removed the 9.61 length, 9.61, that would give me 4.8838, and then some other decimals. Okay, so now that I have that, I'm just going to draw what that triangle looks like down here. So we just found this, it was that 4.8 number. This side we were given, it was the 3.50, and we want to find this side, it was X, and we want to find this angle, it is theta. Okay, so standing from that angle theta, this is going to be opposite. So that is opposite, and then this close side, that is adjacent. So I'm going to use the O and the A, that's going to be another tan. So tan theta is O over A. And tan of theta, we don't know what theta is. Opposite though is 3.50, and then adjacent is 4.8. Okay, and then to get rid of that tan, we got to take tan inverse. Do that on both sides. Okay, so tan inverse cancel, and I get theta equals tan inverse of 3.50 over 4.8. And that 4.8 number, it had all those other decimals in there. Make sure you use all of those decimals. Okay, so when I put that into my calculator, assuming I didn't round, you're going to get 35.6273. So I got theta now. The last thing I needed to find was I just need this X here. Okay, and to find X, that is across from the 90. That is the hypotenuse. So I can use that. And let's say we use this O here. So that's going to be O and H. So I'm going to use sine. So sine is O over H. Then let's fill it in. So sine of the angle was that 35.6273 equals, opposite is 3.50, and then the hypotenuse is X. Put this over 1 and do our cross multiply divide. So X is equal to, cross multiply those two, and divide by the 1 across from the X. So divide by that sine of 35.6273. Okay, and then when you do that, you get 6.008. And then if we were going to round that to the nearest tenth, you get about 6.0. And that was in meters. So now we have found our X, our Y, and our theta. We found all the missing things. So lastly, I'm just going to write our textbook questions. this 1 to 3 here, you guys are only doing A, C, and E. So only those parts A, C, and E. So those are our textbook questions.